Hey everybody, and welcome to our first session of the day here in Theater 2. I hope you enjoyed opening sessions, especially Reggie's part, which will be especially prescient with Vishali's session, which is about using SAS Viya Workbench to build and govern trustworthy AI. Take it away.
Today we are walking through 11 SAS procedures in SAS Viya Workbench that can help you build AI that you can actually trust, that is fair, explainable, auditable, right from development to production. Now, just a quick intro on what is trustworthy AI. Trustworthy AI isn't just a buzzword. It is about making sure the models that we build don't cause harm. Think of it this way. In finance, a biased model lending can deny people homes. In healthcare, a flawed diagnostic model can miss critical conditions. And in public sector, an opaque algorithm can unfairly allocate resources. And that is why we as practitioners should ask the question, should we? Because granted, with AI, we can do anything, right? Now, AI governance is what organizations do to accelerate innovation, manage risk, and ensure that their AI is trustworthy. It is about building that guardrails and having that socio-technical approach to make sure that we are governing the AI in the way it is designed to do good to the people, right? And now you might ask a question, what does this mean to a practitioner, like a developer or data scientist can do for AI governance? There are 5 pillars that a developer, a data scientist, an IT admin can directly shape AI governance. And this isn't just a policy conversation, it is an engineering conversation. Number 1, privacy and security. As developers, the governance starts in our pipeline. We can decide how the data is accessed, stored, masked. Second is fairness and bias. Fairness and bias meaning we own the metrics that a model can ace accuracy while maintaining the bias element, the fairness element of it, right? Think about at subgroup level performance. How is this model doing in terms of bias lending? Is it predicting accurately versus it is predicting fairly? Third is the explainability and transparency. When we are building our models, some people might ask why the model is behaving in the way it is behaving. Regulators or auditors, certainly in finance, may ask why the loan was denied. Clinicians need to know and justify the decisions why they are treating a patient for a particular illness, right? So that is about explainability and traceability, which we as developers can build into our models to make sure that they are fair. The fourth one is auditability and traceability. This means version control, this means model registries, this means reproducibility and governing our models and our data. And last is about monitoring and validation. Now this is like, okay, I have built this model, I have deployed it in production, I'm fine. But deployment is not the finish line. Your data will degrade, your models might drift, and how we can make sure as practitioners that model monitoring is in place. I am going to showcase all of these categories and how you can make sure as practitioners that all of these things are taken care of, right? These are 11 essential SAS procs that you can use right now in SAS Viya Workbench to build the governance at the practitioner level. First is the proc assess bias. Proc assess bias helps us with evaluating the bias metrics and looking at the disparate impact that the subgroup may have in your population. The second one is the mitigate bias statement in the procs like Forest, Grad Boost, SVM, which is helping us to mitigate the bias that we just found out in our model using proc assess bias. And last is proc assess that gives the developers a quick way to evaluate a model on accuracy, confusion matrix per demographic subgroup. So you can spot this fairness gap before anything goes into production. Let's dive into the demo. The demo on the screen that I'm going to show you is about proc assess bias and mitigate bias statement in proc forest. Over here, I have the data set adult from UCI machine library. It is the data set that is a census data set predicting the income greater than 50K for the population. You can see a portion of the adult training input data set there. The next step that I'm going to do is I'm going to run a proc forest model and see how it predicts the target greater than 50K. So it is simple, and you see that the Workbench environment is super light and it's in your familiar Jupyter-like notebook, right? You have the fancy output from our proc forest. Now the next thing that I do as a data scientist is I'm going to see that if my model is working great on the test data. So I did that, then I went in proc a store to store the model results. I'm going to save that into a file. Now, this is the step that we all as data scientists do for predicting a particular target, right? The next step is the proc assess bias. Now on the screen you might see that I have run the proc assess bias for the variable gender, and I see that there are certain disparity when it comes to gender for the prediction. Like the demographic parity, you can see it is 0.16. Now as a practitioner, what can I do to make sure to reduce this parity metric and make sure the model is fair across gender and still maintaining the accuracy? So I am doing a proc forest again, but if you see on the screen, there is a mitigate bias statement which I use to make sure that it is reducing the bias. Now if you see, the observation on the first row is 0.16, and at the 10th iteration it is 0.04. That means we have successfully reduced or mitigated the bias for the particular gender and still maintaining the misclassification rate. So that was a sneak peek into the proc assess bias and mitigate bias statement in the proc forest. The second demo that I'm going to show you is about proc assess. Now proc assess, again I'm using the same data set, the adult data set from UCI machine library. I am doing my test train routine, then I am fitting the proc forest on the data set that I just showed you. Proc assess. Proc assess is giving developers a quick way to evaluate model accuracy and confusion matrix per demographic move, so that you can spot the fairness gap before anything goes into production. So what I did on the screen was just I ran a proc forest, I did my test evaluation, and I'm storing the output using proc store. So it's a very quick way to save your results. The proc assess is the statement that you can use, and it is very powerful to generate your accuracy curves, the ROC, confusion matrix, and over here if you see that I am actually checking the lift and ROC fit statistics for gender female and gender male, because in this case I was interested to see how my lift and ROC works for the subgroup of gender. So all that wonderful assess procedure output, that is actually something that a developer can use to make sure that the model is less biased. Second is the explainability and transparency. Now this is this fun procs that we have in SAS Viya Workbench that you can use for your global explainability and local explainability. Explainability, when it comes to global explainability, proc Shapley can show you how each feature is contributing towards the model prediction. Either it is increasing the probability or reducing the probability. Proc Lime helps you that individual row level explainability in explaining why this decision was made. Proc Partial Depends gives you how a single feature can change the model overall. And of course the proc assess gives you the metrics like ROC and AUC, which I already showed. Let's dive into proc Shapley. Proc Shapley in action, think of it as your feature contributor. You need to explain why the model is doing, how a particular feature is either positively affecting the prediction or negatively affecting the prediction. Again, I'm using the same example, and on the screen over here, I will share the QR codes where you can see this code. It is available in the SAS GitHub repository, so don't worry if you don't follow it right now. So again, I am using the same data, the adult data set. I am fitting a proc forest model. My goal in this example is to use proc Shapley to explain the prediction, right? So whether age is contributing positively towards predicting the income greater than 50K or negatively or vice versa. So it will generate all these plots to make sure that you have that feature level explainability if someone has to show your work. So what I'm going to do is I'm going to select a single observation, a single row in my test data set to explain the prediction. Next comes proc Shapley. This is the powerful procedure that you can use for your explainability at global level. Over here in the output you see the parameter estimates. Over here you can see the work class as state government, for instance, and when I scroll to the right I see that this work class has an estimate of 0.04, meaning it is pushing the prediction up in the positive direction for your income to be greater than 50K. So these are all wonderful feature level explanations that you can have. Second is the proc lime. Now proc lime gives you the explanation for the particular row. It is local explainability. It will explain you locally what is happening to that particular observation. Again, in this example I am using the same data set where I am predicting the income greater than 50K. For proc lime I have to do a certain prep before I can actually run the proc lime. The entire code you can find it in that GitHub repository that I've shared. Now once again since it is a row level explanation, I am creating one row. I am going to explain why this particular observation has that particular outcome, right? So I did the same thing. I ran the proc forest and then I am storing that into a DS2 code in proc store because the proc lime syntax needs it in that format. And then for the proc lime compatibility, I need to remove and keep certain elements of the .sas file, which is what I'm doing now. And this comes the proc lime, which is going to give you that row level explainability for the observation that we selected. And if you just hover over in Workbench, and it will give you all the syntax, the purpose of that proc as well. So it is super easy in Workbench to do that. Now over here, if you see the marital status giving a prediction of positive 0.15, and it is comparing against the base level 0, which means the value of the marital status is pushing the prediction in the positive direction. The third one is our proc partial depend, and sorry, I think it's not doing full screen right now. But in proc partial depend, what are we doing is, if for example I am predicting the target greater than 50K, I have 10 variables. In that, what I will do is I will select one single feature, say age, and I am going to create which values of age are actually giving me positive and negative prediction. So that is what proc partial depend does. It can give you the prediction explanation by varying a single feature in your model and give you the explanation accordingly. So that is the power of proc partial depend, which you can use for your explainability, where if stakeholders want to know how the model behave across the feature ranges. So a quick nugget for you: proc Shapley, it's a feature contributor tracker. Proc lime gives you that local level explanation. Proc partial depend gives you the how the model behave across the feature ranges. Now that was the explainability part. Now comes the auditability and traceability part. How am I going to govern this model, right? So there is a proc within SAS Viya Workbench that you can use called as proc register model. Now proc register model can log your model version info, description, capture all the metadata for your governance registry. Now proc register model is a powerful model when you have access to SAS Viya model manager, right? This is what Workbench can connect your model. It could be a Python model, it could be R model, it could be a SAS model, and we can bring it in SAS model manager to make sure we have that auditability and traceability going on. So here is going to be a quick demo of how we can use proc register model in your native environment to connect to SAS Viya model manager and see it monitor across. So this on the screen you have SAS model manager. I have created an empty project, and what I'm going to do now is I am going to bring in the model into this empty project for its monitoring over time. So here is an example of how you can do it in Workbench. First, I copied the project ID, so I know where to register this model. I am going to use a simple HMEQ data set, and I am going to use a simple proc logistic model. I run that proc logistic model in SAS Viya Workbench, and once I look at the output, I feel great about this model, I am going to register it. So that is the proc register model in action for you. So proc register model is gathering all the wonderful data set, metadata of it, and registering it into SAS model manager. And once that is done, you can generate something called as a model card, and I'm going to show that to you in a second. If you see the proc register model has ran, it has shown you this, and when I go there to the project and I refresh it, I see that the model is present in that. This is the model card you're seeing on your screen. This is automatically generated, giving you the model health indication of how it is doing. And once I run the performance monitoring, it will also show you how it is doing it in production. So that's where the auditability comes into picture. Now, the last but not the least is how do I monitor structural data drift and how do I monitor model drift. So for structural data drift, I'm going to use proc cardinality, and for population stability indicator, which is going to track my model drift, I am going to use proc free. So proc cardinality demo for you. Proc cardinality, what it does is it will see all the categories in the data set for that particular column and will indicate if there has been a certain change in that statistical property. So what I'm going to do is I'm going to run a baseline proc cardinality for my baseline data, and I am going to run the proc cardinality for my current data, which I am checking if it has drifted. So over here I am comparing the proc cardinalities of the baseline data, and I am comparing it with the current data set. I'm using our basic proc SQL to do that. And don't worry, all this code is available on the QR code that I will share. So once that is done, I'm going to use proc print to see which of my cardinality has changed. If you see that in my data set, there is one variable called native country where categories have been disappeared, which means I need to see that, oh, what is happening in that data? And simply I can generate an alert as well to make sure that I have documented it. So I see that, oh, in one of my variable, the categories have dropped. So I need to see why this is happening so that I can go in and check the data drift that is happening. I'm just using and creating a data set of all the changes that have been happened and just printing it with our fancy SG plot. The population stability indicator helps us in understanding how our data has drifted over time. In this, I'm using our favorite proc freak. I'm just importing my data. That is again the same adult data set for this particular example. I am just looking at how does it look like. Then I am making two sections of it, baseline data and the current data for the purposes of the demo. And adding the time indicator for it, Q1 and Q2, because I want to see how this data has drifted, if it has drifted. Then I am doing a proc free for the variable period and race, so that I'll see how my race variable is doing in Q1 and Q2, just to see if that it has drifted or not. I am printing the initial proc free values there, using our favorite proc SQL to make those comparisons of how that data has changed, and it will give me that output as well. So once it shows me the drift status that, okay, this PSI value is less than a certain value that I have set, that means that my data has not drifted. Now, privacy and security becomes very important. We have one proc and one MD5 function that you can use for making sure that your privacy PII is protected. Proc tabular GAN, you must have seen SAS Data Maker, but you can use proc tabular GAN in your Workbench environment to create synthetic data, which generates the synthetic data for you, preserving the statistical property of the individual data set, and prevents you from any PII violations. The second option for privacy and security is our simple data masking, where you can use the MD5 function hashes for sensitive indicators. A quick demo for proc tabular GAN. So proc tabular GAN, I'm using it for a basic HMEQ data set. Over here, it gives you all the options that you would want to select, the method and all those things, and I'm going to run that. It gives me the output of the tabular GAN, all the model information that it ran through, and I'm interested in seeing how my output data looks like, so I'm just using a proc print to see what values it has created to make sure the data quality is intact. So that was proc tab GAN for you, tabular GAN. The second one is the simple MD5 function. There is a QR code on the screen which you can scan for getting a look at this code. So this is a simple MD5 function which gives a hash value for your sensitive variables, and you can use that. You can see that on the screen that I have variables X and Y. It has some protected information and how it has converted it into hash value. So that was the MD5 function for you. On the right hand corner, you have the QR code for the SAS GitHub repository, where I have housed all these examples where you can go in and play around in your Workbench environment or any SAS environment that you might have. And with that, I am going to leave you with some conversations that you would like to have with me on LinkedIn, and I will be at the Trustworthy AI booth. I know this was a very fast-paced demo, but if you would like to know any details about any of the things that you saw in this presentation, please visit me at the Trustworthy AI demo, and I will be there to answer any of your questions there. So thank you for coming.